Alright guys, so it looks like I made a silly mistake when working on this problem, exercise letter E, right? So I'm going to take it from the very last step. I was doing this example correctly, right? So let's see. Having some difficulties here with the pen. Okay, so alright, so I'm going to take it from here where after the step in which we divide out common factors, right? So I'm going to tell you what did I do wrong. So the next step right here would have been to distribute the 3 to get 3x. Okay, let me amplify this a little bit to work more easily. Okay. All right. Okay, let's see. Okay, so it would have been to distribute the 3. That would give us a 3x plus 12, right? And negative 2x. The mistake I did was here when I distributed the 2. I didn't distribute the 2, I just multiplied by, I think I just left a 1, so this should have been a plus 2, all right? And the left-hand side of the equation should remain the same, all right? So let's just drop this, okay? X squared plus 8x plus 6. All right. On the left-hand side of the equation, let's just combine like terms, right? Now let's combine the terms correctly, x's with x's, and that'll give us a total of 1x. And let's combine at the same time pure numbers with pure numbers, or constants with constants. All right, so 12 plus 2, that's going to give us a 14. Okay, something weird is going on with the pen right here. It's doing its own thing or something. X plus 14, okay. And again, the polynomial on the left-hand side still remains the same. Do not attempt to factor it out. In fact, we tried to do it so at the beginning of the problem on the original video lecture, right? So now, first of all, let's move all terms to the other side. Okay, so I'm going to subtract x from both sides, and I'm going to subtract 14 from both sides. All right, that'll cancel, giving me a 0 on the right hand side of the equation. And when we combine like terms on the right hand side, x squared plus 7x, oh, this should have been a minus 14. Okay, let me erase this, let me clean this up. And let's minus 14. No, not minus 14 again, sorry about that. 6 minus 14, that'll give us a negative 8. And in this case, we can solve this polynomial equation by factoring, right? So we're going to look for factors of negative 8 that add up to positive 7. Those factors are plus 8 and minus 1. Okay, so this polynomial was factorable, not like the one I obtained on the other video, in which I did a silly mistake of the distribution and the numbers are highlighted. So by the zero product property, we get x equals to negative 8 and x equals positive 1. All right, now let's compare this with the restricted values. So negative 4 and 1. It turns out that negative 8, right? Negative 8 is an okay solution, right? Negative 8 is an okay solution. However, x equals 1 is not a solution, and that is because x equals 1 is one of the restricted values right here, right? See how x equals 1 that I just highlighted is one of the restricted values. So here, out of the two potential solutions, that is the solution x equals -8 and x equals 1, only x equals 8 is the solution, right? So let's write that down. Only x equals -8 is a solution. All right. On the other hand, x equals 1 is an extraneous solution. And that is because it is one of the restricted values. So if you see an example, if you see a homework problem on your MyMathLab, like one of these in which you have two potential solutions, when you submit your answer, the only one you have to submit at the end is x equals to -8, the one I'm highlighting. That's the only one, because the other one, which is an extraneous solution, we don't look for extraneous solution. In fact, x equals 1 is one of those restricted values. It's one of those values of x that make the denominator 0, and therefore giving us an undefined. So guys, this is the updated version of this problem. So go back to your lecture notes and change the solution you have for this one before. All right, so I'll see you on the next video lecture, which will be solving equations and word problems. Okay.